Have you ever really stopped to think about the sheer scale of the digital services we use constantly, every single day?
Yeah, it's pretty mind-boggling.
I mean, giants like Amazon or Netflix or even Uber, it's not just, making something that works.
Right.
It's building something that has to constantly change, scale up to handle millions, billions of users, and still, well, not fall over when something inevitably goes wrong.
And for years, the standard way was this monolith approach, right? One giant piece of software.
Exactly, a monolith. And imagine trying to change just one tiny thing in that huge structure.
Oh, nightmare fuel for developers.
Totally. It often meant risking the whole system, taking it offline maybe, or just breaking something totally unexpected.
And that exact challenge, that pain point, is really what led to the shift we're diving into today, microservices.
Okay.
So our goal here is to sort of unpack why this architectural style isn't just some tech trend. It's actually a fundamental change that enables, well, incredible agility, scale, and reliability.
Based on the sources we've looked at.
Precisely. We'll dig into the advantages and maybe touch on some trade-offs too, because, it's not always the perfect fit for absolutely everything.
Right. No silver bullets. So microservices. Fundamentally, it's about breaking that big monolith down, isn't it?
Yeah, into much smaller, independent pieces.
Yeah.
Services.
And each one does a very specific job, like processing payments or managing user logins, that kind of thing.
Exactly. And they talk to each other, usually through APIs, these well-defined communication channels to make the whole application work.
Okay, I like the analogy you used earlier, like a factory or maybe a construction site.
Yeah, instead of one massive crew building a whole skyscraper,
Right.
you have specialized teams. One does the foundation, another the plumbing, another the electrics.
And they each focus on their own thing, use their own tools maybe.
Exactly, their own best tools for the job. And then they connect their work together to create the final building. It's a similar idea for software.
Okay, that makes sense. And this way of thinking brings some really big advantages you mentioned.
Yeah.
Like flexibility, scalability.
Team efficiency, reliability. Yeah, those are the big ones we should definitely explore.
Okay, let's unpack that. That factory or construction analogy, it really helps visualize it. But what makes that independence, that specialization, so powerful for software? Where do we start?
Well, I think the first thing, and it's a massive difference from the monolith world, is the flexibility.
Okay.
Because each service is its own little unit. You can update it, fix it, change it without, touching the rest of the application.
So changes are faster. And maybe safer.
Much faster, much safer. You're not deploying the entire application just to tweak one small feature. You're not holding your breath hoping that changing the payment system didn't somehow break user profiles.
Right, I've been there. That fear is real. And that independence must play into scalability too. Because with a monolith, if one part got busy,
You had to scale everything, even the bits that were just idling. Super inefficient.
yeah,
With microservices, you scale only the services that need more resources. So that flash sale example,
right, the product search gets hammered.
you just give more power, more resources to the search service or the payment service. You don't waste resources scaling up, say, the user settings part that nobody's touching.
And that's got to save money too, right, on cloud costs and infrastructure.
Absolutely. It allows for much smarter, more cost-effective resource use, especially for apps that see big swings in traffic.
Okay, so flexibility, targeted scalability. What about the teams building this stuff? Team efficiency.
Huge impact there, too. Instead of one giant team potentially stepping on each other's toes in a single massive code base.
Yeah, merge conflicts.
Exactly. You can have smaller, more focused teams. Each team owns one or maybe a few related services. They can work independently in parallel.
So they're not blocking each other.
Pretty much. Development speeds up because Team A working on logins doesn't have to wait for Team B finishing the recommendation engine. It's like multiple pit crews working on different parts of the car simultaneously.
That makes sense.
Yeah.
And the final piece you mentioned was reliability. How does breaking things up help there?
Well, think about it. In a monolith, if one critical part fails, often the whole application goes down.
Right, single point of failure.
With microservices, if one service glitches, let's say the service that generates personalized recommendations has a temporary issue, the rest of the app can often keep running just fine.
So users can still search, buy things, manage their account.
Exactly. It contains the blast radius of failure. It leads to less downtime, a more robust system overall, and ultimately a much better user experience.
So Amazon's a classic example, right? Their search, their checkout, recommendations, they feel like different parts of the site sometimes.
And behind the scenes, they likely are different services, managed by different teams, updated on different schedules. It allows that massive ecosystem to keep evolving without constant major disruptions.
Okay, so it really changes how you manage and improve large apps. Let's lean more into that development side. How does this really accelerate things for developers and innovation? This feels like where businesses see a huge win.
It absolutely is. We touched on faster development, but it's worth stressing again. Because the services are separate, teams aren't bottlenecked by each other.
Right.
One team can be completely refactoring the login flow, while another is experimenting with a new feature for product discovery. They deploy when they're ready.
That independence must make updates much simpler too. Easier updates, right?
Definitely. You're just deploying one small service, not the whole behemoth. Think about, say, Spotify. If they want to tweak how playlists work or add a new sharing button.
They just update the playlist service?
Roughly something like that, yeah. They don't need to redeploy the entire streaming engine, the user authentication, everything else. This often involves using things like containers. Docker is a common one to package up each service, making deployment even smoother. And clear APIs are key, so services know how to talk to each other even after updates.
Okay, and this leads to another interesting point. Technology freedom. What does that mean in practice?
Well, in a monolith, you're usually stuck with one main programming language, one main database, one tech stack for the whole thing.
Right, you make a choice early on and live with it.
With microservices, each service can potentially use the technology that's best suited for its specific job.
Oh, interesting. So you could mix and match.
Exactly. Maybe a service that does heavy data processing uses Python and a specialized database, while the front-end user interface uses JavaScript and a lightweight framework. Teams can pick the right tool for the job and even experiment with newer technologies on smaller services without affecting the whole system.
That sounds like a dream for developers. I imagine this modularity helps with improved testing too.
Oh, massively. Testing one small, well-defined service is way simpler and faster than trying to run tests across an entire tangled monolith.
You can just focus on that one piece of functionality.
Precisely. Write targeted tests, run them quickly, deploy with more confidence, you catch bugs earlier, faster release cycles.
And Netflix is the poster child for this, isn't it? They're famous for their microservice architecture.
Absolutely. It allows them to constantly roll out improvements, better streaming quality, new recommendation algorithms, UI tweaks without you, the user, even noticing a disruption. That ability to experiment and deploy rapidly is core to how they operate.
Okay, so development speed, innovation, tech freedom. It's clear why developers love it. But let's talk about scale and reliability again. That's where microservices really seem essential for today's massive apps, though maybe not always simple to manage.
That's a fair point. It's definitely not simpler in terms of operations. You have more moving parts to monitor, manage, secure. There's complexity in the distribution itself. It's a trade-off.
Right.
But for applications that need to handle huge scale or require high availability, the benefits often outweigh that operational overhead. Take efficient scalability again.
We talked about scaling just the parts you need.
Exactly. And the cost efficiency of that, especially for platforms with unpredictable growth or spiky traffic, is huge. Remember the e-commerce example during a big sale?
Boost just the payment service.
Right. You're not wasting money scaling parts of the app that are just ticking along normally. It's targeted, efficient resource use.
And that targeted approach helps enhance reliability too. We said if one service fails, it doesn't take down the whole app.
Yeah, think about a music streaming app. If the service that suggests new artists glitches.
Annoying, maybe. But you can still play your existing library.
Exactly. You can still search for songs, manage your playlists. The core functionality remains available. Compare that to a monolith where a similar glitch might bring the whole service down. That's much better user experience.
And finding the source of the problem must be easier too.
That's better fault isolation. The problem is contained within one service. It's like finding a blown fuse in one room instead of having to check the wiring of the entire house. You can diagnose and fix it faster, usually without impacting users of other services.
So ultimately, this architecture is really built to support growth.
Absolutely. It lets companies handle millions, even billions of users because they can scale strategically, add features independently, and maintain reliability. It fits well with how many large tech companies are organized to smaller, autonomous teams, which aligns with something called Conways Law. Basically, your system design often mirrors your company structure.
We see this everywhere in the real world, right?
Yeah.
Uber.
Classic example. Ride matching, payments, driver tracking, all likely separate services, letting them scale globally and add things like Uber Eats relatively easily.
Etsy.
They famously moved to microservices to speed up development on their marketplace, faster updates to product listings, checkout, search, without taking the whole site down for maintenance.
And Twitter, or X now.
Yeah, handling that sheer volume of tweets, timelines, notifications, it relies heavily on breaking those functions into separate services to stay fast and reliable under immense load.
Okay, so wrapping this up, microservices, they really are a fundamental shift. It's about building these large, complex apps as a collection of smaller, independent, collaborating parts.
Exactly. It helps companies build robust systems that can grow, adapt, handle failures gracefully. It improves scalability, reliability, development speed. It empowers teams.
It really changes the game for building and maintaining software at scale.
And understanding this, even conceptually, is pretty useful for anyone interacting with modern digital stuff, which, let's face it, is all of us.
Right.
So maybe a question for you listening is, as you use your favorite apps or websites today, can you sort of sense where this modular approach might be working behind the scenes, making things smoother, more reliable, even if it adds complexity for the engineers building it?
That's a great point. Think about the apps you really depend on. How different would your experience be if a small glitch in one corner could bring the whole thing down compared to this team of specialized services working together? It's a powerful concept, breaking down big problems into smaller, manageable pieces. It really applies way beyond just software, doesn't it?
It really does. A blueprint for complexity.